The project, located in Mascot, consists of 2 towers, of which one is 12 levels tall and the other 13. There is 1 level of underground basement and a podium consisting of car parking and commercial space. Our group was made up of 4 students and formwork was our chosen topic. The site used a combination of formwork for the suspended slabs and then precast walls and columns to reduce the time on the project. Table formwork was used, which provides an advantage for large square floor plates because of fast erection and reusability. Scaffolding was placed around the building and was continually erected above the working platform. A formwork hoist was used on the project. This is a platform used to elevate the formwork to different floor levels in a building. It is a table lifting system which can move formwork through a rectangular prism shaft between the floors of the building or can be attached onto the exterior sides of the building. The table forms can be raised to over 40 meters, and once it reaches the desired story, the formwork is moved onto the floor by shifting trolley or pallet truck. The benefit of this system is that it is independent of the crane. Thus, when the crane is not in operation, the formwork setup and concrete pouring may continue. The apartment block design was square and uniform, allowing for a proprietary formwork system to be used, in this case, table formwork. Each floor and tower was similar in design, so this was repeated on each level and formwork was then reused. This system allowed for fast erection and dismantle and allowed the formwork team to erect roughly 2,000 meters squared in 360 hours, giving an average of 5.6 meters squared of formwork per hour. As mentioned previously, material storage was also compartmentalized and the site had a good working flow. Productivity gains were also achieved by using a formwork hoist, which primarily used to move formwork between each floor. This freed up the tower crane to move the precast elements. There was no scheduling conflicts between materials and formwork being transported between levels. Possibly the only drawback from this system was the workers having to come back after the concrete is set and casting in the penetrations where the formwork hoist moved through. Each tower features multiple tower spanning atriums, and these could have been potentially used instead. A reduction in formwork time was gained through the use of backpropping sequence, allowing 2 floors to be poured before a slab was fully strengthened. A formwork hoist was used throughout the project, which allowed the materials to be easily transported level by level. The benefits are easier access to materials, enabling a more efficient process. However, it meant a penetration had to be left through each level of the building, which was filled in at the end of the project once the formwork hoist was removed. Before any formwork was erected, the surveyor marked out the areas where the formwork was to be positioned. This is an important part of the process as placement needs to be accurate and the markings are there to prevent any ambiguity. The images demonstrate the areas marked out on the concrete slab. The formwork materials were stacked in separate piles to ensure efficiency and improve materials handling. This was both the case for erection and dismantle. For example, the backprops were stacked in one section and the plywood panels and table formwork in another. Materials used include prop extensions, laser levels, plywood panels, and formwork tables. The prop has a 4-claw prong which allows the plywood and the table formwork to sit in place and be adjusted if necessary. An electric pallet truck was used to transport the formwork materials from the formwork hoist to the appropriate location. 2 men were required to lift and position one formwork table as each panel weighs around 20 kilograms. The adjustable prop was erected to the correct height and then panels placed on top. Props are located at each corner of the plywood panels. Once everything is secure and placed, the formwork could be adjusted if required. A worker then checks if the formwork is level using the laser level. They then used a hammer to adjust the height of the props if it was necessary. The HOTI rotating laser is a measuring device which helps level formwork and concrete pours. The laser was used in the table formwork setup and a hammer blow to the pin to adjust the prop levels and panels above. Deckfast is an engineered formwork system that is prefabricated to produce one of the most efficient flat slab formwork systems, consisting of basic deck panels and prop components. The decks are large 21mm thick plywood panels coated with a high quality resin finish for a smooth concrete surface finish. The coat on the plywood is usually a phenolic resin that gives the plywood a hard surface to prevent it from uptaking the moisture in the concrete and allows easy stripping of panels from the cured concrete. The formwork panel is surrounded by a light aluminium frame. Supporting the table formwork are tubular galvanized props or post shores which drop pins and enable the height of the props to be adjusted. Each prop has a stripping pin which, with the assistance of a hammer blow, enable the concrete pressure to be relieved from the shore, speeding the removal rate. Connecting the props to the panels are bearing supports which are inserted in the steel prop secured using bolts or retainers. The bearing supports are captured and secured on the corners of each panel and support the corner clusters of 4 panels. After the bearing supports are secured to the flat top props, each panel and prop can be erected individually, simplifying the erection process. The aluminium frames minimize the gaps between each panel and add strength to it so easier concrete loads can be sustained. Additionally, the frames reduce cleaning, maintenance and cleaning up costs. Between every group of 4 props, 2 cross-diagonal steel braces are fastened between 2 adjacent props, forming a regular box. Removal of table formwork scaffolding will then follow the concrete pour after 7 days. The slab is then back propped to the sequencing shown on the structural drawings. The back propping on the base level can be dismantled after a minimum 28 days once the concrete has reached its appropriate strength. This then allows other trades to access the floor and work on the finishes. The formwork can be reused several times on the project until it's not fit for purpose. Aluminium backpropping are temporary props set up to support the concrete slab once it has been cured but hasn't yet reached full strength. The concrete slab formwork is removed and replaced with vertical props supporting the slab so it may reach the desired strength. This allows work to be done on the top of the slab and around it. This method also allows the modular slab formwork to be reduced sooner, speeding up the process of pouring the next slab.